of the mean of each sample is normal since the data have been determined to be normal.
Okay.
The central limit theorem isn't satisfied because there's not enough. We don't know how many is in the. No, we do know there's only 15.
Yeah.
20 females and 15 males. So yeah, you have to look at the QQ plots to see if it's normal. So.
Right. Okay. Sweet.
So number 4 of the 4 types of confidence intervals, which one is appropriate for this experiment?
Kick that dog.
We don't know the standard deviation. It's unknown.
But we're looking at 2 groups too, so I think it'd be the independent samples.
Yeah, me too.
Okay.
Still dragging behind Louis Storm. And that guy is perfectly sized.
So 5.
Never change.
That basic coming?
No, he was in the water.
People shot at him. No, you can be good in the business. See what I mean? That's that easy to get that damn dog.
So I just did.
Gonna be none.
Shot all the shots and they hit it.
Sorry, what? What was it?
Well, if you hit it once, you shot like 20 shots.
So let's see. 95% confidence interval. So that means it's 2 standard deviations away from the mean. So.
Well, it says what'll produce a smaller margin of error, and I think it would be the obtaining the balances of 90 bank customers rather than 30, because that would be the square root of dividing it by the square root of 90 and not the square root of 30, which would make it smaller.
Yeah, that's right. So it should be obtain a balance of 90 bank customers. I must have been doing 6 on that one. Okay, yeah. That's right, yeah.
Okay. This is the same thing that we did on the review. There's not a big difference.
No, it's exactly the same.
Well, heck, I can just remember what I did on the review and just copy it.
Yeah, right?
I should have written it down. I think I was looking at the math I did for number 6. I got the 998.040. I've done it before, so I'm just looking back at my math.
I got the 996.0208.
Oh, really?
Is that what you said?
No, I said 998.040.
The reason I say that is because I think we have to use the 9.6 confidence interval from chapter 10.
You mean like 1.96?
Yeah, 1.96.
Yeah, that's what I did. I did 1,000 minus 1.96 times. What did I times it by? 2 divided by square root of 4. That's how I got that answer.
So what is 1.96? I cannot remember what that is.
So like when it says calculate the 95% confidence interval, you 95% always in the calculation is 1.96. And if it says like 90%, then it's 1.6 something. Yeah. So base
for the area under the curve.
Yeah. So whatever percentage it is depends on what numbers you plug in. That's back in my chapter.
Okay. Yeah, I see what you did there. I don't know why I got something different. I must have added another number in. Oh, I remember why. Okay. Yep, I added another number in. That was wrong.
Okay. Sweet. How large should it be?
I got 38,416 for this one.
That's what I got too.
I'm gonna do the math real quick.
Sounds
So we're
good.
trying to find out how large. So what equation would you use the?
I just did the exact opposite of what we did for number 6. So you just plug in 0.0001 for your margin of error, and then you do the z-score times the, or I guess it'd be 1.96 times that by the standard deviation over the square root of n, which is what we're after.
Okay. We just work backwards. Okay, that makes sense. Three, 8, 4, 1, 6. What you guys said?
38,416.
Mm-hmm.
Yeah.
Okay. Okay, number 8.
I think it's the first one. Well, I'll let you read it.
Just a bunch of numbers.
Well, why are they just that to the form
So the null hypothesis is h nu 1250, and then HA, the nu, is supposed to be less than 1250.
Yeah,
That. Okay.
Is that what you guys did?
that's what I got, yeah. Or thought.
Okay.
Kendra?
Yeah, what I was confused about is you said the first one, but I forget that our answers are different.
Oh, yeah,
So
sorry.
I don't get how I got that, but now, gotcha.
Sorry, that's
Nope.
true.
Because my first one is, yeah, greater than. So I got really scared because I was like, I don't get this.
I might be, I don't know, I feel like I had the exact same outline as I had when I was doing the review.
Oh, this one was the one in the review where I was like, I'm not sure, number 9.
Sherry Stoker?
Statistical test.
Resend one like you do when you do a text and you make a mistake.
This one was weird because it talks about the sample standard deviations are nearly equal. But we never talked about standard deviations being equal. We always talked about the variation.
Yeah.
Do you do her new every time, or do you have her in your contacts?
So I said yes,
Yeah, I got her address.
just because
You want to send it, or
it doesn't talk about variation or anything like that. So
No, I sent it to the right person. I just spelled it.
So for number 9, I put in a statistical test of hypotheses, we say that the data are statistically significant at the level of significance A if p value is less than the alpha.
Then A.
yeah. Sorry, I skipped.
Nope, you're good.
Oh, you're doing 10, okay.
Yeah, so 10.
All right, yeah, I got the same thing. The p-value is less than alpha.
Okay.
What the?
But for number 10,
It was yes. Because there's enough.
Yeah. Yeah.
Okay. Bless you. Whatever that was.
Yeah, because on number 9, real quick,
Yeah.
if you remember that if the p-value is greater than, then we fail to reject the null, and the null is the status quo type thing.
Right.
So it's normal, it doesn't mean anything. So it's significant if it's lower than the level of significance.
Okay.
Well, they're not fast enough or slow breaking, and so I can't. Well, no.
What type 2 were type 2, you fail to reject, right?
Yeah. So you fail to reject when we should reject it, and then type 1 is we reject it when we should fail to reject it. So, in future studies determine that new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer.
Excuse me. Did we get number 10?
Yeah, 10 you said yes, it is enough that the data.
Our belt shape? Okay.
Yeah. Is that what you got?
Yeah.
Yeah.
Okay.
Yeah, bell shape. So with number 11, the way that I understand it is because the so the null hypothesis is the average survival time after diagnosis is the same for the new treatment and the standard treatment. So both treatments, the survival time after diagnosis is the same. So with that, she rejects the null hypothesis, but in a future study has determined that the new treatment does not increase. So that means we should have failed to reject the null hypothesis because the null hypothesis was true, because neither the new treatment doesn't increase the survival time. So that means they should still be the same. So I put type 1 error.
Yeah.
Okay.
Did you guys get that?
Yeah, that makes sense.
Okay.
Level of significance A is very small, thereby making probability of committing type 1 very small. Ooh, I don't remember this for number 12. Do you guys remember?
Yeah, when you reduce, because you can think of it as the probability. So if this is like your whole probability, if you move it that way, this gets bigger. So this is type 1, this is type 2. If this is small, this is a lot bigger. Because you need to keep it within 1. So the probability of type 1 and type 2 is just equal to 1, I think. Because the probability of committing a type 1 error is just the p-value. So whatever the p-value is outside, if that makes sense. And so the type 2 error is just basically the probability of receiving the null hypothesis. Does that make sense?
Kind of. Not really. So you have
Laughing at you
type 1.
because it was funny. No.
So they do affect each other. Is that what you're saying?
Yeah. So I think what I understand is that they're like inversely proportionate. So if one increases, the other will decrease, and if one decreases, then the other will increase. Does that make sense?
Oh, okay.
Is that right, Kyle?
Yeah.
Okay.
Okay. So I put by reducing the probability of committing type 1, we increase the probability of committing a type 2.
So it's kind of like a teeter-totter type of thing.
Yeah.
Okay. Yeah, I'm a visual learner, so I have to see an image for me to remember things. All right.
Yeah, it's a good thing.
Yeah. Okay. Making content and service distributed with mean and non-distribution of the brand. The mean nicotine content of a cigarette.
I don't remember what I did on this one.
Test the hypothesis. Test the food that you.
I remember I overthought this one.
Yeah, so the mean is larger than the.
So it's not even. It's not even a sixth of one standard deviation away. So it's not even one z-score away. So I would think that at that level of significance, I don't think that we'll be able to reject we won't be able to reject the null hypothesis. So I think it should be failed to reject the null.
Okay. Because it's so close.
Because it's such a small.
That makes sense.
However, let's see, to find the p-value, we have to have. Let's see, I forget how to do p-value.
I think this would be the 1.96. Is that right? For the...
Use the 1.96.
If it's 95,
Oh, wait. I remember there was a thing for this. Where did that thing go?
What is this thing?
I don't remember. Oh, I think you just calculate a normal z-score with it. Okay.
And then use the probability app.
Well, you could.
The applet.
Minus 1.5. I'm going to try this real quick. Standard deviation. Okay. So you just take a normal z-score of this because you have the mean, the normal mean. You have the x bar. You have the standard deviation, and you have a random sample. You have your sample size of 100. So the equation is just going to look like something like this here. So z equals x bar minus mu over standard deviation over square root of n. So if that makes sense, that's what it's kind of going to look like.
Oh, I reduced that equation.
Yeah. And so if you just take the normal standard deviation of it, you get negative, or you just get 1.76, which is less than the 95% stuff. So
95 confidence interval.
yeah, which I don't remember what it is on normal one.
Oh.
It's like 2 something.
Yeah, on the 99, 2 points.
Actually, yeah, because the ones are 68%, 2 is 95%, and 3 is 99.7%.
Okay. Yeah, and that's like the 2 point something.
Yeah.
2.576.
Mhm.
Okay.
So because it's less than the 95% thing, it would be failed to reject.
Yeah. That's what I said. Good job.
Now I remember how I did that. I remember overthinking that for a good little while, and then it just kind of came to me.
So when there's 95% of the data under the
2 standard deviations.
the applet, it's 2 standard deviations, right?
Yeah.
And that is 1.69.
Well, that's when we do the chapter 10 test. I don't remember what that was called. When we have the margin of error, that's when so we use the 1.96 when we don't know the mean, the population mean.
Okay. So in this case, we did know we could figure it out, and therefore find that it was 1.7647. Okay.
Yeah.
Cool.
Yeah, that helps with the explanation. Why?
So if we know the mean of the population, then we can do just a regular z-score type thing.
Yes, which is much easier. That equation is easy to remember and to do.
Rachel back, Rachel T back.
Mom.
Dang.
Hard to be a delta block on an AMI. I don't know.
What?
I think Wes is irritated
With.
with the noise.
So I was looking at 14. From what I remember, I would guess independent sample test because there's 2 groups of people. And
Yeah. So 2 groups that have nothing to do with each other. So yeah, I'd say independent sample t-test.
It's the weirdest things that I remember.
It's a good thing to remember.
I wonder what's going on with Wes. You can tell he's talking to somebody and he looks kind of frustrated. Oh, that's awesome.
He's probably telling his brother off or something.
Oh, it can be hard living back at home. Like,
Oh yeah.
Something that.
I can do it for like a month. Like,
Yeah.
okay, I'm done. I'm ready.
Yeah. Well,
My
it's
little
kind
brother
of
explained some
bad.
stuff to me.
Yeah.
It's kind of bad, but my siblings, they're still in that phase of they don't know what to do around me now that I'm back from the mission. So they don't bug me too much. Today they said, or I think it was yesterday, we had a conversation with my dad. My dad's like, y'all don't bug him or anything?
So
My little brother was like, well, we don't know what he'll do, if he'll get mad or...
Yep, and then we have this, right? Can we find a p-value with this?
Yeah.
Cigarettes, right?
That's funny.
So they don't bug me too much.
Oh.
That's fair.
My
So if it's sort of random, normally
my brother got
yeah,
home and
yeah. It's normally distributed. You know
it,
it's.
like, we just snapped right back to what we were doing.
So I used on the Z-score.
Didn't miss a beat, but we've always been like
It's
just
like
really
almost
almost like too close,
and then where's the
much each
P-value?
other's
The
personal
less the
bubble.
brand advertises that the mean
Yeah.
content is.
He did act weird for a couple weeks. Like he was just like, "Don't touch me," or like just he needed his space a little bit.
Yeah, that's always funny.
Yeah, that's fine.
That's what I had to do a bunch. I just had to act, let people know that I wasn't
There's chit-chat.
just weird or something like that. So I just had to act normal. Because everybody was just like, what's he going to do? How's he going to react?
Yeah.
It's like,
Yeah.
not that different.
Oh, yeah. I just walked through it in my mind.
Sometimes it's the families
called brain deadness.
around him that act more weird than the actual missionaries when they come home.
Yeah. I was reading somebody gave me a return missionary book to help me out. And I was reading about, stake presidents and the parents and all that stuff. And I'm like, why did they read this part? They would have helped me out.
For me. Yeah.
I mean, my dad still has, was weird talking to me.
Oh, really?
Yeah.
That's funny. That's funny.
I know, and a knucklehead. Okay. I was looking at number 14.
Yeah.
And did you guys try to do that one?
We thought independent sample.
Okay. Okay, yeah, cool.
So. And then 14 or 15.
I think 15 would be independent sampling because the brother and sister are separate people who make their own choices. So the brother academic achievement shouldn't depend on the sister's academic achievement. For the dependent sampling, I was reading it has to be the same subject, so it depends on the same subject. Since they're not the same subject, it would be, I think, independent.
And we don't really know if they're doing the same subject. We can't make that call.
Yeah, well, they're doing males and females, and they were saying that it was brother and sister, so...
Yeah. Yeah, those were the two that I looked at as well. As far as... I wasn't sure whether it was dependent or independent.
Nope, that's not it.
Alright, so I think for the next two... we have to open.
Although the dependent sampling, where it says if you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study. So that kind of makes sense, though, too.
Mm-hmm. Those are the two that I had circled. But I honestly don't know which one, because they both fit.
Okay, let me read you guys this question. A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why? So the answer is dependent sampling. He needs to select couples for his sample, so whether a particular wife is included depends on whether her husband is included. So in this case, I think we should have a dependent sampling. Blah, blah, blah. And And then I was thinking that it would be the sister's academic achievement depends to some degree on her brother's academic. No, not that one, sorry.
I
Dependent
was gonna
sampling,
say
if you
I don't
select a
think that's
brother.
right.
Yeah.
And yeah, if you select a brother as to compare his academic achievement
You
to his
must
sister, you
include a
must
sister.
include his sister. I think that would be, it's kind of a weird wording, but I think it has to be dependent sampling.
Yeah, I think you're right about that. I mean, it makes sense that the subjects depend on each other. Maybe their achievement doesn't depend on each other, but the subjects do depend on each other.
Yeah.
And then the one, if you choose the one, then you have to choose the other as
The
well.
other.
Yeah. Okay, that makes sense then. And you're comparing the difference between the two, so.
Yeah.
We.
Let's, ouch. Oh.
I don't want to do this. Okie dokie.
Yeah.
The nice thing is I've already got it saved in here.
That is good. Because mine isn't
already
open
did.
on mine.
Did you ever figure out the firmware thing?
I have. Mine is, when I open it up on mine, it slows everything down. And so when I Skype with you guys, it, like, does the, like, pause. Like, the video will pause and freeze for whatever reason. Like, I can open it on mine, but I can't Skype, or, like, one time I was doing homework and I couldn't listen to music or anything. It just flows way down. So I could open it, but I'm afraid I would lose you guys. Like last time when I lost you guys, that's because I tried to open it at the same time.
Yeah.
So.
That's not fun.
No. So it is downloaded. And as long as I'm not doing any extra things, it works fine on my laptop. But when I'm Skyping with you guys, it just messes up the video. Which it shouldn't, because mine's not like a super old laptop. It's just HP. Yeah, so I've just been using the computers on campus.
Well, that's good. Yeah. I think it's the difference, I think, between your computer and Wes's computer. Because Wes's computer is always kind of, or, his screen is kind of just, I don't know, it's not very smooth. And Kendra's screen is always just good.
Yeah, it's because my computer is not open.
But I had that same problem with my computer, and so that's why I use the iPad now for that.
Yeah.
For 16, I said the confidence interval with standard deviation unknown. Do you all agree with me on that one?
An hour, half hour. Yeah, I think so. No, you guys go ahead.
So how?
No, that's not it. No. Let's see.
So for number 17, does it give you the numbers to do the confidence interval equation?
Yeah, so I got the confidence interval stuff, and I got 11.168 and 15.217. And I did the... So Wes, if I did that wrong, tell me.
Bless you.
Thank you. So I'm doing a one sample t-test.
Okay.
And The thing about the one sample t-test is a lot of times they want you to know the mean or something like that.
Mm-hmm.
You plug the mean into the like the test value, but it is 11.168 and 15.217, so Kyle's right.
Yeah. 11.168.
So we could just do that. Yeah.
Okay. Sweet.
Plumbers, LA and NY, so I gotta do that.
Okay. So it would be a confidence interval for difference of means using independent samples, right?
Confidence interval of mean.
For number 18, the difference of means using independent samples.
Yeah, independent. Yeah, confidence interval for the difference of means using independent samples. Yes.
Okay.
And I can't. I'm looking for the data, but I can't seem to find it.
I've got mine here.
I don't see the data file in the list of files.
That's weird.
There's LA, yeah. Maybe it's just me. I don't know. What did you get for the? I'll just take your word for it, Kyle, because I can't find it. So.
Okay. I am getting. All right. So using the equal variances not assumed, I got negative 423 and 5,417.
Did David have milk or
And
water?
so, are we good with the independent samples? Is that right?
Yeah.
Yeah.
Okay.
Calculate.
So Addie, David came back and came into the house? Just for a drink of water. His dad said he's gonna select it. Unless he's not eating it all right now. That's fragged. Maybe Dad could sit here next to me. Okay. Have somebody who is. You want to sit down here by me, Kev? Oh, do we need this anymore? We need to do cherry harvest chit chat.
Bone mineral data, or
Get that chair over there.
So I think for this test it's going to be a NOVA, right? Because it's got different groups.
I haven't even been able to look at it.
Is it not coming up for you?
No. Oh, well, it says bone mineral density. I'd imagine that's right, even though in the assignment it says bone density. But
Yeah, it should say exercised bone density.
Exercise. Exercise bone density is what it is? Oh, that
Yeah.
explains a lot.
I think it says that in here.
Man, the other thing is the firmware is so slow for my computer.
Yeah.
Like it cannot keep up.
That was my problem.
Grinder. What?
Okay, so I'm gonna do this.
Well, I got 7.978 for the test statistic. And 0.002 for the p-value, which is what I got last time.
Do you remember doing that part?
I remember doing all of this. It's really funny.
So analyze, and we want to ANOVA. Almost there.
Okay.
I'm fine with just taking Kyle's word for it.
Yeah.
Because my computer's struggling. It's getting there, but it's
I don't know.
struggling.
If you need to take your time for it, that's fine, because I don't want to be the only one for making us wrong.
No, I feel you. Okay, let's see. Okay. Yes.
Oh, I should have brought more jam in.
I'm gonna need it right now.
Would you like I got your jam? I think I might be out of jam.
So a Nova
I'll
test.
go see what I can see.
Yeah,
That's
it's gonna
it?
be a Nova test.
Oh. Yeah.
For number 20?
Yeah.
Okay. And then the test statistic is the test statistic should be that's the F value, isn't it? So
Yeah.
7.978.
Yeah, that's what I got.
Okay. All right. And then the p value is, if I can get this thing.
Yeah,
Uh,
I forgot to. So I took off his crust.
Alright.
all right, come on, buddy. Yes. Alrighty. Well.
Who likes extra crust?
Me?
2 soldiers.
It shouldn't be this hard to get the p value.
It's called the Rainy Dish Project.
G at 0.02, Kyle.
0.002. Yeah.
Point. Yeah. Okay. All right. Which of the number 23? Which of the following best expresses the conclusion of this test?
Ow.
0.002, 0.05. So
That was a fun question.
so there is sufficient evidence,
You did well, huh?
Oh, good.
and then
To say-
bone
You did very well.
density.
We both really got
But at
It's
least
different
one
from-
group is different.
Yeah. Yeah.
Was this the class that you just did?
Oh boy.
Filled every bit of the paper in.
One more thing, direct flight.
Yeah.
We're almost there, guys. Almost there.
Anything I could. Just fill the entire
That's right.
paper, all the column, everywhere with just equations and
Literally. We figured out if you filled up the
Hello.
we gave you 75%.
Wrong answer, but I'll use it.
But if you didn't put very much work, how long did you do?
I never stuck out into any work. Just guess on
Oh, it
answer type
smells
thing, and it was
nasty.
just terrible.
Where'd you get that?
Like a 40% on my first 2 tests, and after that I was like, okay.
I would dump
start
that
adding
out.
more,
No, actually,
about
no.
final, I just,
No, all you
and I still wasn't passing
If
for the
I'm
final, wasn't I? I can't remember. It was
It
close.
was close.
I don't know, but I passed. That's all I carried.
You just said you liked it.
No, I never said that.
This one is it independent samples test?
We don't need jam right now, Mom.
Is there any
Uh,
class you guys did?
I think it's the dependent.
Is this in dependent?
But you can have some
Yeah.
water.
Oh yeah, it is dependent. That's
You didn't really
right.
like it in class?
Because it's the same flight, so the same subject, but different
Well, didn't you guys take a
days.
snowboarding class? Yeah.
He did. I didn't.
You did the class too, Taylor? So what
So
would
this one we have.
what would have to
No,
change to make it independent? It would just have to be on the same day?
I'm talking about
Different flights. So this is the same flight on different days, but if you compare 2 different flights on different days,
But you every day.
it would be independent because it wouldn't. It's not the same subject.
Okay.
That worked.
And we want to do.
I'll say a blessing.
Kendra, what song are you humming?
Sorry. I didn't realize I was doing that. Fight Song. It's a new one on the radio.
Oh, it kept putting a song in my head.
What song in your head?
Well, every time I go to the country station, that song "Girl Crush" always comes on.
Can you handle it, please?
And even though it's kind of a dumb song, it's got a catchy tune to it, so it got
Yeah.
stuck in my head.
What is it called?
The Girl Crush.
Oh,
Big Town.
yes. I know. It makes me feel awesome, but it has a really good melody.
Yeah.
It's a really good.
Oh, that's great.
It's funny how that works. The really dumb songs always have a really good melody.
Yeah, I learned it on the guitar last week.
It's like that.
Brothers were like, "Do you realize what you're saying?" I was like, I know, but it's a good song.
You sound like the ostrich off the
Yeah,
side.
you just gotta. You could probably get a good tune out of it and just change the words.
Yeah.
Oh, yeah.
Oh, did you show?
No, I was just gonna have a look.
I think Wes is.
Yeah.
I think he's chugging his food here.
I think of bread, right?
Dying.
I don't want to be.
What?
We're trying to
Potatoes drier than I thought.
think over here.
So for this one,
Skipping a beat, you're just choking.
Yeah, you trying to choke me with your foot?
You take my food.
we do. If this is dependent, then we have to do the
That's my
difference.
Often.
Is that right?
Yeah, so the dependent samples test, and I did the, there's a nice, in the analyze and compare means, there's that nice paired sample t-test, and I just use that.
Six people.
Dad, how did you know that?
And so I got the test statistic as 1.685, and the p-value of 0.096.
I had a hard time finding one. I think
Paired samples t-test. Variable 1, variable 2.
I'll make it.
242. Whenever you're done.
I don't think I've ever done that one before.
It's really nice. You don't have to do the whole difference thing, and it gives you the same thing. Yeah.
I'm just kidding.
Um,
Sorry, guys.
No, you're good.
So the test statistic is, let's see.
Is that what you want?
Diabetes.
No, just kidding.
Or kisses.
I'm just kidding. You need to go to bed now.
1.685.
Yeah,
You need to move.
that's what I got.
And then the p-value would be,
I'm helping you.
well,
I don't know
0.
why it could make that much difference.
Did you get 0, Kyle?
I got .096.
Really? I'm getting sig, 1 pair, 1
You could see
standard,
wet.
and...
that rain, you followed all the way around.
On the wheat or what?
Oh, yeah, you're right. This would be...
Timothy.
I was looking at the wrong one there.
Oh, yeah.
.096.
Or just see it in the dirt?
Oh, shit, in the dirt. Ooh, yeah.
Did it make a difference in the Timothy?
It actually did.
Okay, yeah, .096. And then number 27.
There is sufficient evidence to conclude that there is a difference in the cost of tickets between 14 and 90 days.
Could you give me a little
Perfect. All right. Should we
Which
run through it one more
reminds
time?
me, I just bought my
Just a test.
Nice shape.
What'd you buy?
Need that shape. It's a shame.
Maybe a haircut too.
Haircut.
Did we lose Kyle? Oh, there he is.
yeah, my iPad just kicked me off. Yeah, I just bought my ticket the other day for heading out to Salt Lake, and I got it for $276, and then I had a $100 discount, so it was $176.
Wow.
Sweet.
Yeah,
I almost got played.
That's
it made me
nice.
happy from leaving all the way across the country and here in South Carolina.
That is really
Could only
good.
sleep in like, well, we were in a hurry.
That is good. All right. So I'll read through them if you guys want.
Okay.
Okay, number 1 is true. Number 2 is we are 90% confident. Number 3 is yes, the distribution of the mean of each sample is normal. Since the data have been determined to be normal. Sorry. 4 is confidence interval for the difference of means using independent samples. Number 5 is obtain the balances of 90 bank customers rather than 30.
Is that for me?
Number 6 is 998.04 and 1001.96. Number 7 is 38,416. Number 8 is null is 1250, and alternative is the nu is less than 1250.
They're quite noisy.
9 is the p-value is less than alpha, and 10 is yes.
What's that opposite room?
It is enough that the data are bell-shaped with no outliers. Number 11 is committed to type 1. Number 12 is by reducing the probability of committing type 1, we increase probability of committing type 2.
What? Oh, yeah.
13 is fail to reject the null.
You know what else I can do?
Number 14 is dependent samples t-test. 15 is dependent sampling if you select a brother.
My duh.
16 is confidence interval for nu when sigma is unknown. Number 17 is 11.168 and 15.217. 18 is confidence interval for the difference of means using independent samples. 19 is negative 423 and 5,417. 20 is ANOVA. 21 is 7.978. 22 is 0.002. 23 is there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups.
Yeah, you tell me how much piece you want.
And let's see, number 24 is dependent samples test. 25 is 1.685. 26 is 0.096. And 27 is there's sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance.
Dude, can you cut me a piece of bread?
Look good? Sound good?
Yeah, sounds great.
Cool. All right, I'll submit it. I think it's my turn, isn't it?
I think so.
I don't know. I feel like I haven't done it in a while, but
Okay.
whatever's fine.
Can you pass the butter, please?
So we missed 13 and 13. I think we only missed 13. 13 is we should reject
No.
the
Okay,
null.
so reject the null hypothesis.
Bread.
Yeah, we should reject it. So either we did some math wrong or
So I wonder why that is.
Yeah.
you know what? Let me look at.
Drew, get a tortilla.
Oh,
What? Eating?
What is it?
Can I have the ranch, please?
Oh, thank you.
Eating in front of Drew, not cool.
What's that one where the old man and the
We figured that it was what was the z-score? Dang it.
1.76.
Yeah.
1.76
Yeah.
is the z-score.
Yeah.
The area is 0.07. Oh, wait, no, it's 0.0392. So that makes sense.
It was.
Yeah, because you've got to divide it by 2.
Yeah, so that makes sense.
Big star?
Okay, that's what I get for not looking at the applet. Sorry, Wes.
Yeah, I was gonna say no, you're good because I thought the same thing. I was like, I should just go get the applet, but
I couldn't find the applet either, but I was too lazy to go look for it.
it's in. Just so you guys know, it's in lesson 5. That's where I always get it.
Oh, that's right.
Okay, so yeah, number 13 is reject the null.
It's so wet.
Should be good after that.
Yeah, I submitted it. It was right. So.
Cool.
100.
Awesome, guys.
Oh, really?
Good luck on the test.
Yeah. Do you care if I just email you about Tuesday?
You're going to need a bigger boat.
Or text you either way?
Yeah, that'll work.
Awesome. All right. Yeah. Good luck on the test. We'll see you guys Tuesday then.
All right, sounds good.
Okay.
Adios.
Yeah, have a good weekend.
See you guys.
Bye.
Bye.